Okay, second day of the grand experiment. So let's go ahead. Yesterday we talked about circumference and arc length. Today we're going to talk about the area of circles and the area of sectors and segments. Okay. So let's go ahead and get started. First thing you have to know is, how do you find the area of a circle? Okay. Well, the area is the number of square units enclosed in a figure. And for circles, we find it by the formula area equals pi r squared. So let's go ahead and find the area of these circles. In the first example, the 3 and 2/10 is actually the diameter. So remember, the radius is half that. So half of that is 1 6/10. And then I can just plug it into my formula, pi r squared. I always put numbers first. It's out of habit. The commutative property says it's okay to do that. And so if I square 1 6/10, I get 2 56/100 pi. And the directions told us to leave it in terms of pi, so we're done. In this second circle, we already have the radius. It's 2 5/10. And we're going to go ahead and just plug it into the formula. So the area is going to be 2.5 squared times pi, or 6 25/100 pi. Note over here, I didn't put the measurement. Let's get used to putting in the measurement. So the first circle, we need to add inches squared. Okay, this definition said square units. So area is denoted with inches squared, feet squared, whatever. All right, so different kind of problem. We're going to work the formula backwards. We know that a circle has an area of 15 pi, and we want to find its circumference. So if I find my area formula and I plug this stuff in, area is 15 pi, and that equals pi r squared. So I've got to divide both sides by pi. And when I do that, I get 15 equals r squared. If I take the square root of both sides, the square root of 15 is approximately 3 87/100. Okay, now we were asked to find the circumference, so now that I know the radius, I can find the circumference. So remember, the circumference is 2 pi r. So 2 times 3 87/100 times pi is going to give me about 7 75/100 pi. If you wanted to know what the actual was, you could just multiply that by the pi, and we would get what would we get? 24. So about 24 33/100. Okay. On the next lesson, okay, we're going to talk about a sector. And a sector is a region bounded by an arc of a circle and the 2 radii to the arc center. So here is my 2 radii, here is my arc, this area in here is my sector. So it's just part of a circle, and they're always going to be defined by the center and 2 rays, or 2 sides of an angle coming off from them. If I want to find the area of the sector, I'm going to take the measure of arc AB, okay, and divide it by 360, because that's what proportion of the circle it is, and multiply it by pi r squared. So in this case, the measure of arc AB, because it's a central angle here, the arc is 45 degrees. So it's 45 over 360 times 3 squared times pi. So 45 over 360, and I don't want decimals here. is going to be 1/8. So we have 1/8 times 9 pi, and so that gives us an area of 9/8 pi, and we can just leave it in terms of pi. Okay, remember, when we leave it in terms of pi, it's the exact answer, and when we multiply it by pi, it's an approximate answer. All right, so let's take a look at this example. Put that arc in there. Okay, here's my sector. I know that this is going through the center, so that's a semicircle. This whole arc is 180, but I've got 120 taken up. So this angle is 60 degrees. So this arc is 60 degrees. 12 is my diameter. So that means that my radius is 6. So when I plug everything I know in, I'm going to get the measure of arc AB is 60 over 360 times 6 squared times pi. 60 over 360 reduces to 1/6 times 36 pi, and 1/6 of 36 is 6. So the area of that sector is 6 pi. Okay, now we have another thing we wanted to find, and that is a segment of a circle. And a segment to me is kind of deceiving because it's a line when we're just talking about segments. But what happens is, with a segment, we take the area of the sector and we take the angles, the ends of here where they intersect, and we draw a line. Okay, and that gives us a triangle. So a segment is this part right here where that line is outside of that triangle. So that's my sector. And the area of the sector, to find the area of this, would be to take the area of the sector, subtract out the area of the triangle, and we get the area of a segment. So just again to reiterate, if I have a circle and I draw an angle, a central angle, and then I connect where it touches the circle, what is outside of that is your segment. All right, so let's look at an example. We want to find the area of the segment shown. So remember, we take the area of the sector, subtract out the area of the triangle, and that will give us the area of the segment. Okay. So the area of my sector, that's a right angle, so this is 90 degrees, is going to give me 90 over 360 times the radius squared times pi. So 90 over 360 reduces to 1/4 times 9 pi. So I get 9/4 pi for the area of my sector. Area of my triangle, remember, is 1/2 base times height. And it's a right triangle, so my legs are my base and height. Because that leg is a radius, it's also going to be 3. So it's going to be 1/2 times 3 times 3, or 9/2. Okay, and if I subtract them, that gives me the area of my segment. Because this pi, if we're leaving it in terms of pi, we can't combine the 9/4 pi with the 9/2, so we just say that the answer is 9/4 pi minus 9/2. If you wanted the actual measurement in decimal form, you could just multiply 9/4 times pi, and that gives you about 7.068, and then subtract 9/2 from that, and we would get approximately 2 57/100. So a couple steps involved in finding the area of a sector. Let's do one more example. Okay. It's kind of hard to see this one because we don't have a height. We don't have a base. We don't know what they are. So we've got to do some trig in order to do that. So this angle is 60, so this little one in here is going to be 120. Okay. Now I can take that and I can draw the altitude. So now that little angle in there is going to be 60, because that's half of 120, and we know this radius is 4. So what I've done is I've made a right triangle out of the radius and that one angle. Half of 120 is 60, and my radius is 4, which is the actual hypotenuse. And then this is 30. And actually, we don't have to use trig because I have a special right triangle. So we know that in a special right triangle, the hypotenuse is twice the shorter side. So if my hypotenuse is 4, then this is going to be 2. So this right here will be 2, okay, and this will be 2. So my whole base in this case is going to be 4. The height is going to be this side right here, and that is 2 times, and I screwed that up. Dang it. No, I didn't. Yes, I did. All right, so guys, I'm gonna start this over example, because if that's the 30, 60, 90, then the 30 is the smaller side is the altitude. So this is what's going to be 2. And opposite the 60 is going to be 2 root 3. So this is 2 root 3. This is 2 root 3. So that's going to give me 4 root 3 for the base of my triangle. And the height is 2. All right. So let's find the area of the sector. So we've got this area of the sector minus the area of the triangle. Okay, so the sector, since that's 60, my sector is 120. So 120 over 360 times pi r squared. The radius is 4. So 120 over 360 is 1/3 times 8 pi. So 8/3 pi is the area of my sector. The area of my triangle is 1/2 base, which is 4 root 3 times your height, which is 2. Well, 1/2 of 2 is just 1. So I've got 1 times 4 root 3, which is just 4 root 3. So the area of my segment is 8/3 pi minus 4 root 3. In this video, in this lesson, things that you need to take out of it. How do I find the area of a circle? How do I find the area of a sector? And how do I find the area of a segment? Those are the important things that you need to pull out of this lesson. Have a great night.